Good morning, guys.
Good morning, sir.
I hope all of you are doing good.
Yes, sir.
Very good. So today we are supposed to start with our first topic, which is measure of central tendency, right?
Yes, sir.
Okay. So uh, anyone knows anything about what is measure of central tendency? What we are supposed to learn here? Any idea, anyone? No, no one knows anything.
So, from what we studied in till class 12, the measure
Hmm.
of central tendencies are mostly mean, median, and mode. And
Hmm.
they talk about they summarize the representative part of the data.
Yes, very good. Okay. Any more? Anything more? Anyone? Okay. All right. So let me explain this measure of central tendency with one example. Okay. So suppose I am planning to do some study on the students in your class. Okay. So so let us assume I want to perform a study where I want to see whether age has something to do with how much time you spend on screen, whether you're watching TV or you're checking your phone. So does age has anything to do with that? Okay. So if I want to do this study, so I need at least two variables from this class. Number one, the age of each student, and number two, how much each student is spending in front of the screen, right? Now let us assume we have 20 students in this class. So I have 20 observations for age and 20 observations for screen time. Now, of course, I cannot remember these 20 figures for age and 20 for screen time all the time. Okay. So now I am going somewhere and I met a person who also has same interest, who also studies these kind of behavior in students. Okay. Now I want to discuss my data with that person. And suppose I am not carrying the data with me. So if I had to say something about my data, how will I describe? So I can describe my data using something called as point estimate. Okay. So point estimates are nothing but some points, estimate of some points in my data set that can talk a lot about my entire data set. So just by explaining this one point, I can give the estimate of my entire data set. Okay. So there are different type of point estimates, and measure of central tendency is one such point estimate. So what this measure of central tendency does, it basically finds out the central position of my data. And how this central position is going to help me in describing my data. So I know according to the distribution of any variable in the population, so the central position is very important. So most of my data points are centered around, or most of my data points are present around this central position. Okay, so we'll learn this concept in detail later on. So for the time being, whatever is the central position, most of my data points lie close to this. Okay, so if most of the points are lying close to the central position, so if I say something about what is my central position, so that means I am talking about a large number of samples or large number of individuals in my sample, right? So if there are 20 students and I say that point estimate for my these 20 samples for age is say 20 years. So now I know most of the students in this class are either 20 years of age or close to that. Okay, so just by telling this one number, I am basically describing my entire data set. So now here we have 20 students. What if my data includes say 500,000 individuals? Okay, so it will be difficult for me to handle that kind of data if I have to describe someone all the figures. So I cannot tell each and every number. Okay, even if I start scrolling all the numbers, after some time I'll be tired. Okay, I'll be bored by scrolling this many numbers. So point estimate or measure of central tendency is one such method where just by telling a single point, a single number, you can talk about your entire data set. So measure of central tendency basically gives you the central position of your data set. Now, we have three different ways to find out this measure of central tendency: mean, median, and mode. So depending on what kind of data you have, what kind of data distribution you have, you can decide whether you should find out mean or median or mode for your data. So if you are dealing with qualitative data, like I told you yesterday in my last class, whether you are talking about gender. So if I have to find out how many males are there, how many females are there, okay? So that is a qualitative data. So if you have qualitative data and you have to find out measure of central tendency, so in such cases, mode is the only method. So you cannot find out measure of central tendency with mean or median. Mode is the only way. If you have quantitative data, then you can apply any of the three methods. You can calculate mean, you can calculate median, you can calculate mode. Now, depending on what kind of data you have, one method may be better than other two. Okay, although you can calculate all three, but under certain conditions, one method is more appropriate as compared to other two methods. All right. Understood, everyone? So far, what we have discussed. So this is the basic idea behind measure of central tendency. So if anyone has any question, any doubt?
No, sir.
All right. So then let us discuss these different measures in detail. So for that, I want you guys to see a video first, and then we'll have discussion. We'll have question answers and we'll discuss it. Okay. So watch this video first. Okay. So I am starting the video now.
If you're new to the channel, it is great to have you. Welcome. If you're a returning viewer, it is great to have you back. If you like the video, please subscribe, give it a thumbs up, and share it with classmates, colleagues, or friends, or anyone else you think might benefit from watching. So now that we are introduced, let's go ahead and get started. So this video is about mean, median, and mode. Now you may have heard of these before, and on their own, mean, median, and mode are not difficult topics. However, what I want to do in this video is threefold. One, I want to visualize them for you wherever possible. Two, I want you to understand the relationship between the three. And three, I want you to be able to develop judgment as to which is appropriate given the data you have. So let's go ahead and get to work. Now with mean, median, and mode, what we are beginning to do is measure the center of our data. Now, the center of a data set is absolutely foundational to everything else that you're going to do in statistics. We use it in hypothesis testing, we use it in regression, and many, many other things besides that. So let's go ahead and get these fundamental building blocks out of the way. First, the mean. Technically, it's called the arithmetic mean because there are other types of means we can calculate, but this is the simple one that we are used to, and it's just the average of all observations in the data. You've probably calculated the average of numbers before. It's often taught in grade school, so it's not anything that's all that unfamiliar to you probably. The next is the median. And for students just starting in stats, this can be a new concept. But basically, the median is the middle observation of a data set. So what we do is we sort them from smallest to largest. And if there are an odd number of observations, it's the one literally in the middle after sorting. If the number of observations is an even number, the median is the mean or the average of the two numbers in the middle. And we'll see that in a couple minutes. The mode is simply the observation that occurs most often in the data, or the most frequently occurring observation. Now, a data set can have one mode, it can have multiple modes, or it could have no mode at all. It simply depends on the data you have. So first, the mean. So here are some salary data I created. So we have 12 observations and 12 salaries. So to calculate the mean, it's very simple. We add or sum up all the observations and then divide by the number of observations in the data. So in this case, we would add up all the salaries and then we would divide by 12. And in notation, we denote that by what's called X bar. So it's an X with a bar over the top. So step one, we sum our observations. When we sum all of our salary data, we have $1,291,400. Step two, we count our observations. Now notice I have the word length in parentheses there. The reason I have length is because length is often how we describe a data set when we're doing programming applications. So in programming, when we have a data set like this, it's basically what's called an array. So the salary data here is an array with a length of 12. So as students get more into coding environments, I like to describe things in ways that you're going to see in code. But if you're not into that or not going into that, it's simply the count of the number of observations. So in step three, we just divide the sum by the count or the length of our data set. So we have $1,291,400 divided by our 12 observations, and we end up with a sample mean of $107,616.67. So that is the mean or the average salary of our 12 observations. So next we have the median. So here is our data, same numbers, but I put it in a horizontal format, and you'll see why here in a second. So observation 1 is 65,600, and so on and so forth. So to find the median, first, we sort our data from smallest to largest. So we can see here that we have a small salary of $29,500 all the way up to the maximum salary of $500,000. So they are all in order from smallest to largest. Next, we ask ourselves, is our data odd or even length or an odd or even count of observations? If it is even, as it is in this case, we then just divide it in half. So you can see here I have the first 6 observations shaded in a gray, and then I have the last 6 observations shaded in sort of a light brown. And because this data is an even number of count or an even length, we just divide it in half. 6 on one side, 6 on the other. So here's where we left off. Now, since it's even, we find the mean of the two middle values. So we can see here that observation 6 and observation 7, those are the two middle values on each side of that dividing line. So all we do is find the average or the mean of those two values. So we have 73,600 plus 78,800, and then we just divide that by 2. So our median in this case is $76,200. So what if our data set has an odd number of observations or is an odd length? Well, in this case, we just simply divide our length or our count of observations in half and then round up to the next number. So in this case, we have 11 observations. We divide that in half, so we get 5.5, and then we just go ahead and round up to 6. and it's the sixth value that is our median. So in this case, it's 73,600. If you notice that on either side of the sixth value, we have 5 below it and 5 above it, and the 6 is situated right in the middle. Now, mode is very straightforward. It is the observation that occurs the most. So in this case, we have 2 salaries of $54,000, and quite simply, that is the mode. Now again, data sets can have more than one mode. So if we had 2 salaries that were $78,800, we would have 2 modes. We'd have a $54,000 mode and a $78,800 mode. And some data sets don't have a mode at all. If all the values in our data set are unique, then none of them has more than one observation, and therefore there is no mode. And this is actually a warning. The mean can be influenced by extreme observations, either low and or high, that are different from the rest of the observations. So here's our data set from before. Notice we have someone in our data set that has a salary of $500,000. Now look at the other 11 observations. They all tend to be around like $75,000, give or take. So our sample mean was $107,616.67. However, our median was $76,200. That is a massive difference, a huge difference. And the question is, which measure is more accurately representing the center of our data set? So an analyst could inaccurately represent the center of the salary data. This mean over here is much higher than the median due to the presence of someone making $500,000 when everyone else is around $75,000. Now also, a good analyst would double check that value. They would double check the data to make sure that extreme observation of $500,000 is not a data entry or recording error. In this case, it could be really easy to type in $500,000 when it's supposed to be $50,000. So if you do have an extreme observation in your data, don't just say to yourself, oh, that's just how it is. No, go back, look at your data, look at the records you have, look at everything you have at your disposal to make sure that data is valid in the first place before beginning with your analysis. So our final concept is called the trimmed mean. So here's our data set again. Then what we do is we sort them smallest to largest like we did for the median. And then we remove the same number of observations from each end of our data set. Now sometimes this is expressed as a percentage, like a 5% trimmed mean or a 10% trimmed mean. So in the end, it doesn't really matter so long as you are removing the same number of observations from each end of the data set. So in this case, we will remove the smallest of $29,500 and we will remove the largest of $500,000. So from there, we just calculate the mean again. So in this case, we have a sample mean, or original sample mean, of $107,616.67. Our median was $76,200. And in this case, our trimmed mean is $76,190. Now, look how close the median and the trimmed mean are. They're almost identical. So by removing the same number of extreme values on both ends, in this case, we got a value where the trimmed mean and the median are almost identical. So what we can do is conclude that that's probably the best representation of the center of our data, and our original sample mean is heavily influenced by that person who had a $500,000 salary among 11 other individuals who had salaries around $75,000. Now here's a note. Trimmed means are better for a single variable, what we call univariate. So uni meaning one, variate, variable. Once you get other variables involved, relationships between variables are created and things become much more complicated. Now, however, there are methods for trimming or removing multivariate extremes, but that is beyond the scope of this video, and I do actually talk about that in more advanced videos in my playlists. So when you are doing a univariate analysis, what I would recommend is reporting all three of these values. Report your original sample mean, the median, and then a trimmed mean, either 5% or 10% or something like that. So as long as you include the original sample mean with the trimmed mean, that's perfectly fine. However, never leave out the original sample mean. You got to have both so you can compare the two, and of course have the median in there. Okay, so a quick conclusion and then we are done. So the mean, median, and mode can provide information about the center of your data. The mean is the most often used. However, the median can sometimes be a better measure. The mean can easily be influenced by extreme values, so be careful. Extreme values may be a recording or data entry error, so double check your original data. Look for a large difference between the mean and the median. It could be a warning sign that you have an extreme observation that is pulling the mean in one direction or another. And finally, a trimmed mean can also be calculated and reported, which chops off the same number or percentage of observations on both ends of the data. And again, always report that with the original sample mean. Okay, so that wraps up this video on mean, median, and mode. Again, on their own, very simple concepts. However, we want to visualize them. We want to understand the relationship between the three of them and then choose which one is the best depending on the data we have. And again, that's very important. So thank you very much for watching. I appreciate your time, and I will see you again in the next video. Take care.
All right, guys. So now let me explain this particular topic again. So let me share the slides with you guys. Okay, so what we are talking about is measure of central tendency. And in measure of central tendency, we have three different ways to calculate it: arithmetic mean, median, and mode. Okay, um, like mean is of different types, and we generally use arithmetic mean. So we have geometric mean, harmonic mean, weighted mean, trimmed mean. There are different types of means, but that is beyond the scope of your syllabus. So you guys have to focus only on arithmetic mean for this particular course. Okay, so what we do in a measure of central tendency, we basically find out the central position of the data. Okay, and that is generally called as average. And these are the three different ways with which you can calculate the measure of central tendency. All right, so how do you calculate the mean? All of you know, we just have to add all the numbers and divide that total with the number of observations. And this is the fancy way of representing mean. So mean is represented by x bar. So you see there is a bar over x. So that is called as x bar. Okay, one very important information. So these are also called as point estimates, because just by estimating this one point, you are talking about the entire data set. So they are called as point estimates. Now in the first class, I guess I told you something about sample and population. So whenever you are calculating a point estimate for the sample, it is always denoted by some English letter. And when you are calculating a point estimate, same point estimate for the population, it is denoted by some Greek letter. Okay, so this sample mean is denoted by x bar, while the population mean, if you are given the population data, entire population data, and you are asked find out the mean, so that will be denoted by mu. Okay, so the sample mean is denoted by x bar, and the population mean is denoted by mu. So mu is nothing but summation of all the observations, that is x, divided by total number of observations, that is n. Okay, so what are the properties of mean? So and why mean is so popular? Because first of all, you can do all the mathematical operations on the mean. So you can subtract it, you can divide it, you can multiply it, you can do n number of mathematical operations on mean. It is very easy to calculate also. Okay, so there are certain things due to which mean is pretty popular. So easy to calculate. It is based on all the observations that you have. You can do mathematical operations, and if you change certain observations in your data, so that may change your mean value also. So these are some of the merits, and the demerits are definitely it is influenced by the extreme values. You if you have missing values, that is going to have impact on your mean, and if you are dealing with qualitative data, so there also you cannot calculate mean. So that is one of the demerits. So suppose I am finding out how many males and how many females are there in the class. So I am taking data on gender. So I know gender is a qualitative variable. So there I cannot calculate mean. So for qualitative variables, I can either calculate the proportion or percentage, like 50% males, 50% females, or proportion, zero point 0.6 is male, zero point 0.4 is female, like that. Then the next measure was median. So as shown in the video, if you have extreme values, so you just by calculating the mean, you may not be able to find out the central position. Okay, so in such cases, instead of calculating mean, we go for median, and median tells us about the central position. Okay, so it is the central value, and to calculate mean, what we do, we follow two steps. So the first step is arranging the data. So you arrange your data either in ascending or descending order, and then you find out the middle position. So in order to find out the middle position, the formula is n plus 1 divided by 2. So n is your number of observations. So suppose you have 11 observations. So 11 plus 1 is 12. 12 by 2 is 6. So sixth observation in your sorted data, the data that is ordered in ascending or descending manner. Okay, so when you use the formula, you are given the position, not the number. Okay, so if I'm collecting data on age. Okay, and so the first step is I arrange all the age groups in descending or ascending order. Now, if I have say 11 observations, so 11 plus 1 by 2 is 6. So the sixth observation is my age. So let us assume at sixth position, the age is 50. So then the median value would be 50 for that particular data. Okay, and if you have, like I told you, I have 11 observations. So what happens if I have 12 observations? So 12 plus 1 by 2 is 6.5. I know 6.5 is the mean value of sixth and seventh position. So what you have to do, whatever values you see at position 6 and 7, add those, divide that by 2. So basically you have to calculate the mean of values present at sixth and seventh position. So that is going to be your median. So this is the same thing that has been explained. So like here we have 12 observations. So the okay, I think they are 13 observations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Right. So we have 13 observations and they are arranged in descending order. So 13 plus 1 by 2 is 7. So you see at seventh position, the value I see is 12. So for this particular data, the median is 12. Here is the case where we have even number of observations. So we have 1, 2, 3, 4, 5, 6. So we have 14 observations here. So 14 plus 1 is 15. 15 by 2 is 7.5. So we basically have to take 7th and 8th position. So at 7th position we have 27. 8th position we have 29. So calculate the mean of these two, 27 and 29. So that is 28. So for this particular data, we have 28 as median. Now, the quality about median is it doesn't matter whether at both the ends what values you have. It is not going to change. So it is not getting affected by extreme values at both ends. So you see at one end we have value 17, at other end we have 40. So it doesn't matter whether we have 40 here or 4,000 or 4 million. Median is going to be 28 only. And similarly on other end, whether it is 17 or 0.017, the median stays the same. It is not getting changed. So why we should use mean or median or mode? So or when we should use? So depending on what kind of data you have. So if you have qualitative data, of course, you cannot calculate mean or median. In that case, you can calculate mode only. Mode can be calculated for quantitative data also. Okay, but if you have qualitative data, then mode is the only way to find out the central position. Okay, and for quantitative data, you can calculate all three. So if all the observations are quite close to each other, mean is the right approach. If you have extreme values, you have to go for median. Okay, so you have to see the kind of data you have and the distribution. If you do not have any extreme values and your data is quantitative, go for mean. Okay, so that is all for the. Okay, guys. So I hope all of you understood this concept.
Yes, sir.
Okay. Yes, I can see Manaswini has some doubt. Yes, Manaswini.
Yes, sir. Sir, so in the video, he had talked about how sometimes in a data set there can be either very high or very low values, and this
Yes.
could in a way disrupt the mean. So in cases
Right.
like that, we use the median. But after that, he also talked about the trimmed mean. But if we're already using the
Yes.
median, why would we need the trimmed mean?
If we are using already,
If we are already using median for cases where there are very large data points, then why would we have to why would there be a use for trimmed mean?
your voice is breaking again and again. Can you repeat your question once more, please?
Sir, can I type my question in the chat box?
Yes, that also you can do.
I'll just do that.
So as far as I understood, you are talking about what is the difference between trimmed mean and median? Is this the
Yes, sir. Yes, sir.
question?
That's my question.
Okay. See, both are two different things. If you have extreme values in your data set, so generally we go for median. Okay. If you calculate the trimmed mean, so the trimmed mean will also give you the values which are very much close to the mean. So depending on what is your requirement, you can calculate both median or trimmed mean. So median is always one value, right? But for trimmed mean, you can have different trimmed means. So like you want to have 5% trimmed mean or 10% or 20% like that. So if it is 5%, you remove 5% of the observations from both ends. If it is 10%, you remove 10% of the observations from both ends. So depending on your requirement, you can go for trimmed mean. So for simpler calculations, we generally don't do trimming. So what is the problem with trimming? So you are basically removing those observations from the data set. right? So if let us assume you have 100 observations and there are 10 values that are extreme at both ends. So you will remove these 10 values. But while removing those 10 values, now you are left with only 90 observations. So you are not removing only, so if you are dealing with say monthly income and there are 10 people who are earning quite high or very low, okay, so what you basically are doing, you are removing all these 10 individuals from your data set. Okay, so if you are working with only one variable, that time it is not going to make much difference whether you're calculating median or trimmed mean. But if you have like you have collected say 20 different variables from these 100 individuals, so while giving this point estimate for one variable, so you have to give point estimate for other variables also. So if you're trimming your data based on this one variable, you are trimming the 10 observations for other variables as well. So that is going to have impact on your data size. So this is the a major difference. So depending on whether you have one variable, you are studying one variable or you are studying multiple variables. So you have to decide whether you should go for median or trimmed mean. So for one variable, it doesn't make any difference. For multiple variables, if you have, it is always better to go for median because then you are not doing any trimming. I hope it is clear.
Yes, sir, it's clear. Thank you.
Okay. So any other doubt, any other question? Anyone?
Sir, could you please repeat the difference again? Actually, my network was kind of very poor.
Difference between this trimmed mean and
Yeah, yes,
median.
sir.
Okay. See, for trimming, so you are removing certain observations, right? Now let us assume you are working in the field of cardiovascular diseases. So in order to understand this disease, you are collecting certain variables from your study sample. So you are collecting their age, their gender, their physical activity, blood cholesterol level, their fat intake. So lot of variables you are collecting from these individuals. Okay, and you are mainly interested in like how much uh, time they are giving for the physical activity. So every day how much physical activity they are doing. So you are collecting this data in terms of minutes. So how many minutes you are doing exercise every day. Okay, so some people will say we don't exercise at all. Some people will say like we exercise 60 minutes. There may be people who are saying like we exercise 4 hours or 5 hours a day. We are fitness freak. Okay, so you'll be having both the extremes. So some people with zero time, some people with quite high, like 300 minutes, 400 minutes in a day. So now if you have to calculate the mean, so you may not be getting the actual central position because of the extreme values present at both ends. So in that case, you have both the choices. Either you calculate trimmed mean or you calculate median. So for median, you are considering all the observations that you have collected. But for trimmed mean, you have to remove certain observations on both the ends. So it may be 5% of the observations or 10% of the observations. So while doing trimming, if you are removing say 10% observations, so if you started with say 100 individuals, so you are left with only 90 individuals now. Okay, so if your focus is on all these variables together, so trimmed mean is not the right choice. In that case, go for median because you are not compromising with the number of observations you have. You still are considering 100 observations. But if that is not your concern, if suppose your concern is only about how much time they are giving for their physical activity, in that case you take median or you take trimmed mean. It is not going to make any difference. Understood?
Yes, sir.
All right. So any other doubt, any other question, please ask. Any one of you? Okay, so yes.
So what if there are like in a data set there are two values that occur in the same number of times? So what would be the mode? Because mode would be the
Okay,
highest.
so all right, so it is, so while calculating mode, so we basically see which number is occurring most frequently. So let us assume I am asking you guys, what is your favorite fruit? Okay, so someone will say apple, banana, orange, like that. So we may have different situations. So suppose I collected 100 observations. So I asked this question from 100 students. Out of this 100 students, say 20 are saying oranges. Okay, so that means mode is oranges here. Now let us assume another situation, 20 are saying oranges and 20 are saying apples. So the number of students who like oranges and number of students who like apples is same. So in that case, you have two modes. Okay, so 2-point estimates here. So such data set will be called as bimodal because you have two modes in the data set. If you have only one mode, that is called as unimodal. Understood?
Yes, sir.
All right. So any other question, guys? Okay. So I'm giving you a, all right. So you have a book. I would suggest you try calculating median, mode, and mean. Okay. So generally students make mistake in calculating median. So my request to you all is please try doing some examples from the book. Okay. If you face any difficulty, do let me know in the next class. All right, guys. And you all are supposed to find out the answer for a question that I'm asking right now. You have to tell me in the next class whether these mean or median are real numbers or hypothetical numbers. Okay. So you have to search for this answer for this question. In the next class, you have to tell me the answer. I'm going to ask this question again in the next class. So read about it, try solving some questions, and we'll discuss whether you have any doubts. Once your doubts are clear, then we'll move to the next topic. All right, guys?
Excuse me, sir.
Yes.
Can you repeat the question again, please?
So the question is, you have to tell me whether mean and median are real numbers or hypothetical numbers.
Okay, sir.
Okay. All right, guys. That's all for today then. Thank you very much. Bye bye. Have a nice day and a nice weekend.
Thank you, sir.